Hello everyone and welcome to today's webinar where we'll be taking a look at demand response and how it can benefit your business and importantly cut costs. My name is Stephen Kennett and I look after the Energy and Carbon Management channel here at 2 Degrees. I'm delighted to welcome our presenters today. Joining us from Open Energy we have David Hill, Business Development Director, and David Perry, Operations Director. And we're also fortunate to be joined by Martin Newton, Assistant Director of Estates at the University of East Anglia, who's going to talk about his experience of implementing demand response. Today's presentations will last for around 25 to 30 minutes, which will leave us with 10 to 15 minutes for questions at the end. Before we begin, I'd just like to remind everyone that you can submit questions throughout the webinar using the Q&A box on the bottom right-hand side of the screen. Just type in your question and press send, and then we'll wait till the end before answering as many as we can. As an aside, if you should have any technical issues during the webinar, please use the chat box on the right-hand side to send me a message, and I'll get back to you as soon as I can. So without any further delay, I'd like to hand over to David Hill, who's going to get us started with today's presentation. So David, I'll hand over to you.
Thank you very much, Stephen, and thank you very much everyone for joining today. As the title suggests, today we want to kind of outline what is demand response and why is it important for your business over the kind of coming years. Because at Open Energy we really believe that demand response is really the most exciting innovation to come out of the world of the smart grid. And I want to start by explaining first what it is, but also I want to spend quite a bit of time understanding why demand response is important. Because it's important to understand it in the context of the wider energy market and what is it we're trying to displace and what is it we're trying to achieve. After that, I want to kind of describe a bit more about Open Energy's position in the demand response market, and then David Perry is going to describe a bit more about what it actually is we look to do on site before, as Stephen said, Martin described some of his experiences of the technology. And firstly, I want to start a bit about sort of explaining what demand response isn't, because as with all very exciting new market spaces, I think there are a few myths that often get kind of gossip out in the market space that aren't true. Demand response isn't an answer to in response to the UK capacity crunch issues. Fundamentally, that supports the need for demand response, but demand response is an innovation that would happen without capacity crunch issues. Demand response also isn't only a response to an electricity market that is becoming more and more delivered by renewable generation. That intermittent supply supports the need for demand response, but again, it would happen without that. And most importantly, demand response is not a crude, blunt instrument that turns off your important and critical processes in response to national grid or utility signals. That is demand response done badly, and your processes are paramount in demand response. Now, moving on to slide 1, I think it's important to understand the whole electricity value chain, understand what it is demand response is trying to displace. Fundamentally, the electricity value chain is something that hasn't changed really since the very first power station was built in London in the 1880s. We go around the world extracting and mining fossil fuels. We then centrally generate that. It goes through to the transmission and distribution network, goes to the electricity supply companies, and it goes to you, the consumer. Now, that whole electricity value chain has been built backwards from the idea that demand is static. We look at every one of your businesses' electricity demand curves, and fundamentally we build a value chain all the way back from the one assumption that we can't change demand. Now, it's easy to say that, but that there builds catastrophic inefficiencies throughout the whole electricity industry because of this notion that you can't store electricity, and that this notion is demand is a very static thing. One of the most pressing examples of this on the next slide is, in the UK, we have about 135 gigawatts of installed generation capacity, of which last year only 35 gigawatts was utilised. That means 75% of the time the generation capacity in the UK is doing nothing. Now, some of this is slightly disingenuous. About 10% of the time, a lot of the generation capacity is offline for maintenance purposes. But that still means the need to build new power stations is very much for this notion of peak demand. If we had an ability to flex demand at certain times a day and make better use out of existing infrastructure, that would bring transformational benefits to you, the consumer. That will have transformational benefits in wholesale electricity prices, which is about 40% of the cost of electricity, and in the transmission and distribution of that electricity as we make better use out of the network infrastructure, which amounts to about 20% of your electricity bill, and in the way we balance the electricity, which is what I'll get onto in a bit, which amounts to about 3% of your electricity bill. But fundamentally, if we debunk the myth that demand is not a static thing, we can make much better use out of the infrastructure in the electricity industry, which will benefit you, the consumer. And so then we get brought onto this notion of this idea called the new energy economy. Now, the new energy economy is a very exciting space for consumers because the demand response has come out of this notion of this thing called the Internet of Things. Because we can measure and monitor everything your electrical assets do in real time, we have been able to understand that there is flexibility in places where people didn't believe there was flexibility. And when we understand what this flexibility is, we can begin to make your businesses participate in the electricity industry in ways that you couldn't before. Businesses used to just be passive consumers, and electricity was essentially a cost center for businesses. Demand response is about looking into your business processes and understanding the flexibility there that we can trade into the system and actually make your business profit from this transition to the new energy economy. The new energy economy is going to need a significant amount of investment over the next coming years to enable us to meet our carbon targets. And most businesses over the years have assumed that is a cost to their business. Actually, by embedding demand response into your processes, you can profit from this transition. And the future is quite an exciting space for open energy, because when you have a generation which is predominantly renewable, of which the marginal cost of production is nothing, and you have a demand that is automating the intermittency of that, of which the marginal cost is very little because we're just looking at data costs, we have a system that is very cheap to run. But in the meantime, as we transition to that, there is a chance for you, the consumer, to make money out of flexibility that you have in your system. And the reason this is really exciting is because the cost of building a demand-side power station, which Open Energy is trying to do, is significantly cheaper than the alternatives. If we look at in this graph, we look at the alternatives, which are battery technology, pumped hydro systems, or traditional thermal power stations, the cost of building a megawatt of flexibility from the demand side, which is essentially integrating all the flexible demand that we see in your businesses into our portfolio, is very cheap. And the reason it's cheap because it is already built. The heating and ventilation assets, the air conditioning assets, the water pumping assets, the bitumen tanks out there, all these assets are already built and we just have to connect with it. And that is the reason that this is a very exciting market space and one that is here to stay, because essentially building this is much cheaper than building a power station. Now, what does this actually mean for your business? Because again, it's a very exciting space, but how do you actually make money out of this? Now, this slide I've put together is designed to be a little confusing, if I'm honest, because there are lots of new value streams in which you can make money out of your flexible demand. And I sympathise with energy managers because undoubtedly there are lots of people bombarding you all the time with different demand response propositions, because there are, as in every new evolving market space, there's a lot of complexity and a lot of noise. Essentially, if we look at the left-hand side of this slide, there is most demand response markets come out of UK balancing services. Now, Open Energy is no different to this. Balancing services are procured by National Grid. National Grid accrues about £1 billion a year in its pursuance charges on people's electricity bills, and it buys a bunch of services. Now, I'll spend a bit more time later on describing these services in a bit more detail, but fundamentally, National Grid pays for speed in these services. The quicker you can respond to an event, the more you get paid. And so therefore, in these response services, the dynamic frequency response and frequency controlled by demand management, they tend to often be rewarded slightly higher than reserve services like store and DSBR. If you move right, we get to peak price avoidance, which is probably the most known type of demand response. Triad management services have been around for a while, and the cost of using energy in these peak times is only going up. And utilising flexible demand to shed as much load as possible during these hours is incredibly rewarding to businesses. Likewise, in certain in certain areas of the country, distribution network charges are incredibly high, and shedding load during these periods is very lucrative for businesses. And then if we move right in the sort of orange colour, we've got the capacity market, which is due to come in 2018. Now, if I'm honest, the capacity market has not been designed very nicely for demand-side response. Essentially, you get asked to respond within 20 minutes and asked to hold indefinitely, which is not necessarily applicable to a lot of businesses' processes to be turned off indefinitely. However, by 2018, it is hoped that by virtue of providing balancing services, we'll be able to provide our customers with a capacity payment just by virtue of helping balance the system. And if we move right again, distribution networks are looking into building their own demand-side response markets, but they, especially the ones in UK Power Networks in London, is looking at building a demand response market for flexible demand. Now, again, that is very regionally specific and sometimes not applicable to certain businesses because you have to be connected to a specific substation with an issue. And then lastly, probably one of the most exciting spaces is this idea of energy trading. As more and more customers move to flexible buying contracts, we can actually sort of manipulate your demand in relation to system prices and electricity prices to optimize your demand against that. And there is a lot of value there. However, in this sort of quite complex space where there's lots and lots of different markets to operate in, understandably, you have to start somewhere. And actually, whilst this market is very evolving and moving, what Open Energy has found over the last 4 years is actually your demand and your assets is something that's quite static. We've noticed that when you switch a refrigeration compressor in a supermarket, you can switch it very quickly, but you can't hold it off for very long. Conversely, if you switch a water pump, you might not be able to switch it very quickly, but you can hold that asset off for a period of time. From the bottom up, we can understand what is possible from your estate in terms of flexibility, and then we look into the market and understand where's the best place to play with that demand. And fundamentally, there's only a few places that make sense at the moment. And that's why Open Energy has spent a lot of time building its product in the firm frequency response market. This slide here just shows you the amount of money that National Grid gets year on year for balancing services, and you can see that steadily over time it has been growing. But I want to bring you back to why frequency response is such a compelling place to start demand response services, because essentially it suits the needs of the system and the needs of the consumer in the most organic way, in the sense that we can command the highest price from balancing services from National Grid with making the least impact on your site and operations, because as Martin might allude to later, we are only making switch recommendations for minutes at a time. We're not asking for too much of your appliances. Essentially, we're trying to align the duty cycles or electricity consumption of your appliances to the needs of the system, thereby you just get paid for business as usual. Again, this describes a little bit about system frequency. If you are unaware, essentially all the generators in the grid are spinning at the same frequency, 50 Hertz. What happens is when the frequency drops, it means there's a shortage of supply onto the system. It's rather like if you're driving a car and you're driving at 50 miles an hour and you come to a hill, you need to give a little bit more throttle to maintain the same speed. The electricity market is exactly the same. So when the frequency drops, we look to see if we can turn a few appliances off. Conversely, a power station looks to put a little bit more supply onto the system. Likewise, if frequency rises, which happens quite a lot, especially with influx of wind energy, we need to see if we can absorb that energy. But it's important to always understand that we're not looking to waste energy there. We're only looking to absorb energy that can be absorbed. So bringing forward a cycle from a compressor, or bringing forward a pumping that needed to be pumped anyway. Sorry, 1 second. Let's go back there. So this slide, there's quite a lot of information on this slide, and we're happy to share this with people after the event if they're interested. But essentially this gives you a bit more of a breakdown of the specifics of each of the balancing services market where most demand response companies play. And it shows you the specification of frequency response, that we need to respond very quickly, but the average duration of response is not very long. And what it shows you there is the price per megawatt per year is overwhelmingly larger than all the rest of the services in balancing services. But as I said, I won't spend too much going into this detail because you can look at this after the event. But what you'll begin to see is that all the other services tend to put more and more of a stress on the systems of your demand. If you look at FCDM, frequency controlled by demand management, whilst it is a very fast-acting service, you actually get no warning of when this is going to happen in your system, which is not a very useful service to plan for as you go throughout the year. And here's just a kind of a graph to just hit home again the comparative value differences in dynamic demand frequency response versus the competing demand response solutions on the market. Now, the one over on the right, Triad there's a slightly sort of maybe misleading, because actually on a half-hourly basis the cost of Triad is dwarfs all the rest of the services. But however, that is only for 3 settlement periods of the year. If you annualize that, the pounds per megawatt hour you can get from dynamic frequency response is much larger than store frequency control by demand management and Triad costs. Now, without further ado, I will pass you on to David Perry to give you a bit more of an insight into what we're actually looking to do on each side.
Thank you very much, David. And hello, everyone. Very nice to meet you all. So what we look to do slightly more specifically at a site level for dynamic demand is we would engage with a potential partner. As we'll talk about a bit later on, there is naturally a cost of installation in terms of hardware and people. So what we would look to do to try and provide a relatively robust business case at an early stage, once we have surveyed the site, as David said, to profile which of the demand services it would fit, if it fitted FFRR service, if we can get between 50 and 100 kilowatts of availability at a site level, and we'll talk about what availability means, then generally the payback is pretty good. Ancillary services alongside of that are provision of data, clear evidence of what's happening with operations, and in certain instances we build a network to enable us to operate, as we have to send data back to National Grid so frequently. The critical term we talk about a lot in open energy is availability. And what we mean by that, quite simply, is out of the proportion of power the load is pulling at any one time, what can we influence with a power change without at all impacting operational processes? It's very critical to us that the asset continues to do what it is always doing, and as David said, we are time shifting forwards or backwards, something that load would already do. A fan would modulate on or off, a pumper might pump a bit earlier, a refrigeration compressor might move. And as we are an aggregator with National Grid, we look at availability as a combination of assets. So on one site, we may have a fan, a heater, a boiler, a tank, and what we would do is blend them all together at an aggregated level, but each asset operates uniquely and individually from itself. We treat everything as an individual client to us and an individual energy storage. So on this side, I think the critical things to take away are availability. And 100 kilowatts, as I said, it can be 10% of a megawatt load. It can be 100% of a 100 kilowatt load. So what we're trying to do always through the pre-work that we do with our client partners is understand the asset class. So, and I'll touch on that in a minute. How would we integrate with it? So is there a way in? And what is the operational process? And the operational process, absolutely critical because that determines availability, which ultimately determines revenue. So on the next slide, as I say, there are suitable assets for us are really quite varied because what we're looking always to understand is where is the stored energy in that process. So in refrigeration, for example, the stored energy is in the frozen food. So how much time have we got where we can modulate that fridge before the operational parameters of that load are impacted? We have fans and heating ventilation, and Sainsbury's, one of our first clients, we were balancing the fans in 200 of their supermarkets. We operate with water pumping and with motor-driven loads such as compressors, and we have a lot of industrial heating loads at the moment. Bitumen tanks are great energy stores, as you can imagine, because of the energy in the bitumen, and we're working with foundries where the energy storage is in the holding pots or in the molten metal itself. And what we're always doing is, as part of our engagement process, is to work out can the process of that load react in time to the grid requirements for our service, which are very specific. If it's FFR, it needs to have started to react within 2 seconds, have reached maximum power by 10, and under optimum conditions, last for 30 minutes. But as David said, our average switch time, and one of the earlier slides said that, is much shorter than that, 2 to 3 minutes, because the grid is very good, to be honest, at balancing itself. What we're really there for is a promise. We're saying if there's an imbalance in there and a power station tripped out, we would, if we had to, be able to turn more on or off than we needed to do. But what we're doing, therefore, with National Grid is providing to our client partners a recurring revenue. As David said in one of his earlier slides, there is a balancing market. We tender the load into that and generate revenue from it. We do save carbon. We're not having to burn power stations because, as David said, the electricity has already been generated. It's in the assets. We're just using it slightly differently. We're looking to see how we can operate with the process. And one of the things we do see in periods of time after we've installed, because we have to meter sub-second and monitor so granular level, we can often talk about the operational processes and provide information back on how the assets are operating to see if there's any scope to flex or to see if there's anything we can do with it. And as we said, we do provide data back to our clients. We have to meter everything very accurately for National Grid because that's the provision of service. They audit us on what we've done as the grid moves. So the asset criteria, quite simply, and maybe it sounds a bit trite, is it needs to draw electricity from the grid. There needs to be a power change that we can enforce. we looked that the asset has an operating range, a parameter that we can influence. So on the example of asset criteria that we talked about earlier, it's got a temperature band that it has to meet, it's a pressure level that it needs to operate within, it's a water level it has, and those bands give us the flexibility to be able to modulate the power consumption. Certain asset classes and certain processes have no flexibility. For the operational process doesn't tolerate it. About 5 years ago, we surveyed a chemical plant when they were doing blister plaques on the ibuprofen, and the air pressure in that plant had to be kept to such a fine tolerance that there was no flex. Even though they had lots of chillers, they were not available for us because their pressure had to be so tight. And we derive that through all the pre-work we do before installation. What we look to do, therefore, is the operating range, talking about those examples that allow us to modulate the power change without impacting the primary purpose of the asset. The primary purpose of the asset always is in control. The asset is telling us if it's available for us to switch. If it isn't, it's excluded from us. And if it is and it's under the right conditions, we would look to modulate, but for a few minutes, not for very long generally. But as we said on my first slide, there is a sort of a power that we look to have because we do put assets on site for sure. We would install standard components for ourselves. One is sort of an industrial PC called the Tritium Jace, which is where we house the algorithm, which is the device that is listening to frequency and is listening to the load saying we're controllable. We have a 3G comms back to National Grid, so we have a router, and we put meters on site. And we have to have a frequency meter, obviously, to measure frequency locally on the grid. But what we do there, and spend a lot of time doing, is understanding how best to integrate. We've got 4 or 5 integration options. We can create a network, go through relays. For example, of water companies, we can talk through a PLC network. Martin is going to talk about the UEA, where we've integrated through Martin's trend network. So we have ways in there, but the critical part of our installation process is to make the load give us a signal to tell us if it's ready to do anything. Some loads, as you can imagine, are more ready to do that than others, and therefore the implementation is a bit faster. Some, as I say, we put a network of infrastructure around it to give us signals back. But fundamentally, always, we put in standard components, and the objective is to not influence negatively the process, to enforce a power change, and then to report all that back to National Grid. Without the reporting back, fundamentally, we don't have a service. So when we're installing that, as I said, there is on average a cost, and it's probably on average, as I said, between £5,000 and £10,000 a site, including hardware. Slightly determined by the complexity of the site, what has to go in there, and we can cover capital costs, but always we would look for that to be a negotiation with the energy partner at the other side. Some clients want to invest and some clients want us to do that. Typically we get 2-year payback, as we've said, on these sorts of installations, and what we do is look to sort of phase the rollout to ensure that there's benefit given back early to show the proof of concept of the service, and equally to show that we're doing what we say we're doing. We have to be, because of the provision of service to National Grid, completely transparent in what we're doing. Again, as Martin will show on his trend network, Martin's able to see exactly what we're doing because the network provides that. So we're always transparent in what we're doing, we're transparent in the service it provides, and we take the open part of our brand very seriously, to be honest. That we have to integrate at quite a detailed level with the operational process to make sure we don't influence it, except in a positive way, and therefore we like to make sure that everything is visible when we're doing that. And this is just, as I say, we're going to pass over to Martin in a second, but these are some of the case studies of companies that we are working with at the moment. And across that group, there's the whole combination of assets that I talked about in my earlier slides, from water pumping at UU, bitumen tanks and water pumps at Aggregate Industries. We've got boilers and chillers at UEA, at East of England Co-op. Sainsbury's was our first installation. We have HVAC, and we're just doing refrigeration with them now. Canals and Riverside is water pumping down in Devizes. Costain is a strategic partner for us. So what we're always looking to do is build a long and valuable relationship, partly on the way that we integrate, partly on the service that we provide, and partly on the data that we give back. So I'm going to pass over to Martin now, if that's okay. And I say, again, I'm happy to answer any questions at the end.
Right. Well, good afternoon. From our perspective, we looked at this, okay, let's take the risk out of it to a certain extent, and let's do it in phases, and let's look at, in with open energy, which of our assets we could control. So this was our first phase. Sainsbury Centre for Visual Arts is an international art gallery, but it's got an awful lot of air handling plant that to a certain extent the customer doesn't really know if they are running or not. There's 40 air handling units down either side, and they can run, and they're running permanently, but we can switch them on, and actually they're all on variable speed drives, so we can actually speed them up a bit. Similarly, Nelson Court, Constable Terrace are both residences. There we have the air handling units that take out or supply air into the residents' bedrooms and take it out of the shower pods. But actually those two also have electric heating in those air handling units. So again, we could control that, and that energy could be stored in the building, in the fabric. Then we've got our low energy buildings, ZISA, Zuckerman Institute of Connective Environmental Research, and then some of our, well, I've actually put ZISA there twice, some of our teaching buildings. But again, they are thermally massive buildings with air handling plant that is permanently running, but they're all on variable speed drives and all on our building management system, so that we can actually know what's happening to all these assets. And these are ones that we felt our customer wouldn't necessarily know, that we're actually controlling them slightly differently. So it was a case of, well, okay, why not? Our second phase, which we've done a few months later, once we've got a bit of confidence that the system was working, our customers weren't noticing it, we carried on with some of our low energy buildings. But then, the main university library has an air handling plant, quite a big one. It's a 10,000 square metre building that's constantly supplied with fresh air. Okay, we can control that one. Similarly, the lecture theatres are slightly more complex because we can't ramp them up too much when they're occupied, but within parameters. Similarly, the sports park has got lots of air handling plant, some pumps doing the swimming pool and the likes. And then the last one, our laboratory fan dilution sets are permanently running, but we don't allow those to vary during the day because there might be a slight higher risk to maintenance operatives on the roofs of these buildings. So those ones we allow to come in during the night. The next one I've got in our next slide, this is just a shot out of our building management system. It's a trend building management system that controls all our buildings. And oddly enough, my colleague actually managed to pick out an event here, and you can see down in the bottom right-hand side where it says open energy, it's actually an increasing event, and you can see the two air handling plants are both, the two main fans are actually both at 100%. They are normally on a variable speed drive, compensating for the filters that slowly get blocked, and as the load varies downstream, if a floor closes off, those two fans will back down. So this event is actually where it's increasing and both fans are going up to 100%. So it's all controlled in on our site, all via the building management system, which we already had on site, that is controlling all our assets. So to a certain extent, we've still got total control. And if it isn't available because we've got a particular event going on, a particular problem, or we've got some maintenance going on, we can disable the open energy input into our system, and then we don't get rewarded for having that availability, but it's not influencing our customer experience. What I've got next is just a slide of how often, and this is actually the same air handling unit that's actually being called for. That's roughly about a 24-hour period, and from 0 to 1, that's when it's actually increasing the load slightly, and the 0 down to -1, that's when it's actually in a decreasing event. And you can see the width of the bands, the maximum, the middle event, the darkest blue one, I think that was about 9 minutes. Sometimes these can be 15, 30 seconds. I don't think I've ever seen an event more than about 12 minutes on our site, but to a certain extent, it doesn't really happen. Our customers don't know it, so I don't often look at this unless the customer actually says, what happened last night? I can actually look at this and see if it was an open energy event actually caused them to experience it, or was it just something happening on our building management system, or something that someone's manually done. So this is just giving us information from all our systems. We've got, just the sort of summing it up. Why did we do this? I mean, when Open Energy came and I sort of understood the systems and what it was doing, it was a case of, well, hold it, I get money. I get financial reward using my existing assets. Now, we actually went for a strategy to the low risk in the fact that we didn't actually put up any capital. Open Energy paid for the capital to put it in. So I was getting money without actually any capital investment. So, okay, I've got a low risk to the business, and I've still got control of it if it is having an effect to my business. So I felt it was low risk, financial reward. I've got no capital outlay. And then the bigger picture of me started to think, well, this is the right thing to be doing to help the national grid. We know the national grid is in a changing world with renewables all coming on. It's the right thing to do for the country. The more security we can put into our electrical system, and it's much better to be doing it cleverly on the demand side, rather than on the actual supply side by bringing up power stations. And it is the right thing to do for the planet. If we can reduce our CO2 emissions but still provide the service, it's a case of, why shouldn't I do this? This is a reasonable no-brainer for me. I'm getting money. I've still got control. I haven't put out any money. And it's the right thing to be doing for the planet. So that's to a certain extent why we've done it. And we're now thinking about a phase 3. We've got some more assets, ice core stores, some of our big catering areas. There's other buildings, other things that we can think of in working in with what is the capital outlay, and is it big enough load, and can we vary it for long enough that actually gives a financial reward that outweighs the actual capital outlay to put it in, and we get some money back. So we will continue with this type of thing. So I think that sort of concludes my thoughts. So Stephen, are you going now to control?
Great, thanks Martin, that's fantastic, and thank you to both Davids for their presentations there. So we're going to go into the Q&A session now. So maybe a good question to begin with is someone's asking, what are the factors that affect the installation cost? So is it down to how much energy you're consuming, or how many bits of plant or systems you might be looking to include? David Hill, do you want to maybe pick that one up?
He's still there. You there, David?
I can have a go at that, Stephen, if David.
Okay.
So generally, the factors affecting are not really to do with any consumption. It's mainly the amount of plant that we're installing on, but fundamentally, it's how do we get at those assets? So if we take a bitumen site where there are 4 discrete bitumen tanks that aren't networked together, we've built a network around that. We've effectively built a building management system around those. In Martin's site, where he's done a fantastic trend network, we were then integrating into Martin's network. So some of the cost, as Martin showed on one of his slides of the 963, was to put our software into Martin's network and allow it to talk. So, as I say, if we're creating the network, there's maybe a bit more hardware capital outlay, which is still within the 10,000. If it's the network already there, it's allowing the network to listen to us, and that's maybe more software than hardware, I would guess. Do you agree with that, Martin?
Yeah. No, it's obviously what assets you're going to control and how long you can control for and how much it's costing to install. I do have some more loads potentially, but it's going to cost too much because they're not on the same LAN. So then, as they would have to have a separate piece of equipment from Open Energy on each asset, it isn't going to be economic. But it is just the economic case of size of load and how much it costs to put in.
And then the process that it is. So if it's, as Martin's loads are available, he said there's some constraints. One of the site is only available at night for us. So we build, that's the bit about the process piece that derives availability, which is where the revenue is come from. But we pick all that up through the survey. It's very site dependent, to be honest. But in general, it's how do we integrate with it? So how much hardware have you got to put to get there? And what is the process deriving to give us availability and revenue?
Great, thank you. Next question, Martin, one for you, is how do you prioritise what plant was included?
Just by understanding well, we have a good idea what each asset is likely to be consuming. We know that's a big air handling unit, crikey, that's going to have a big motor on it. And, yes, that one is one that our customer wouldn't notice. Other ones, you go, oh, no. Either risk to that operation, it's I won't say, but an animal laboratory. No, we're not playing with that one. That's too much of a greater risk. So it is knowing and understanding your loads and which ones you think are big enough and which ones you think aren't going to necessarily affect the end user customer experience or the primary role that driven our thoughts down, really, I suppose.
Great, thanks, Martin. Another question here. You mentioned the idea of increasing the heating or cooling loads in the buildings to store the energy in the fabric of the buildings. And the question is the increased energy cost associated with the increased energy delta offset by the rewards for participating?
Essentially it's David Hill here, by the way. What I wanted to sort of stress when we did that is essentially you are only bringing forward energy consumption in the parameters of what the control parameters are in the first place. So essentially you're not incurring an energy penalty, you're just bringing forward consumption that will not happen at a later date. If the temperature is within parameters or the pressure of the compressor is within parameters, essentially that unit is saying I can go on at this point in time, and essentially because it can go on, you can turn it on without incurring an energy penalty. We do rigorous analysis during the first sort of month or so of our installation where we baseline it. We turn the algorithm on one day, off one day to give absolute assurance to our customers that we are not incurring them an energy penalty, so they can be happy that essentially our service is energy neutral. If for some reason or other the system seems to be off more than it is on, and therefore there is more high availability, which is to turn the asset on, we can restrict the high availability we get from an asset to, again, ensure there is no energy penalty. Fundamentally, there are a few things that are the most important things we do with our customers before we make any money. One is don't affect operations. Two is don't affect energy costs. The third thing that is important in what we do is to give money, but it is the third thing. The other two are of paramount importance.
Great. Thanks, David. So another question here is, someone's asking, is the payment linked to current energy prices?
No, it's linked to balancing the prices for ancillary services. So as I said, we tend to load into the dynamic firm frequency response market, of which the prices are quite public on National Grid's website, and we structure a deal with all our customers to make sure there's a good deal on the table to make sure it works. But essentially, it's not linked to the wholesale cost of energy; it's linked to the cost of balancing the system. Which in my slides earlier, it costs about £1 billion a year to balance the system, and the price we get is about the average price of firm frequency response, which is on National Grid's website.
Great, thanks, David. Another question here is, how quickly can end users begin participating? What's a typical sort of timeline?
Installation. From an installation perspective, I guess, from the point of an agreed scope within a month, I guess. So there's quite a bit of pre-work that goes on that, as Martin was saying, to identify and profile the usable assets, to agree that the process is in. And once we've got that scope agreed, it's within a month, I would guess, installation. And then, as David said, we baseline that for a little bit. And if it's a load site that we've operated before, then we have some provenance in that with National Grid and about how we choose to qualify things. But a lot of the pre-work, really, the effort goes in as part of the sales cycle, is in identifying the asset, agreeing with the end user, Martin, in this instance, to say, out of your whole portfolio of loads, what do we think is within scope? But from the point of the agreed scope, I guess it's about a month.
Yeah. The installation bit is relatively quick. It is the pre-thought of what loads and what is the parameters where it is going to engage or disengage.
Great, thanks, Martin. And a follow-on question is, depending on the systems you've got installed, do you need to shut them down during the installation process?
I guess it's me again, it's David. Yes and no, not always. If you're installing meters, there will be a period of time when if we're putting a meter in, that needs to be depowered for safe working.
Yeah.
The rest of it, I think, is integratable as part of the process of the load.
Yeah. No, from a safety point of view, yes, I think we did isolate panels, but not for relatively long. The panel, the CTs can go on relatively quickly. The panel can be, pre-installed and the rest of it beside. So no, the installations weren't particularly long, and of course they were assets that we could allow to be varied and go off for a period. And some of them were done at particular times that wouldn't interfere with our core business. So no, I don't think installation was particularly a problem.
And with just in regards to when we've worked with a sort of retail environments and supermarkets, there is no sort of disruption to store operating hours during the installation. The store can operate as normal as we install.
Right. Another question we've got here is for frequency response, what frequency denotes an event and what frequency denotes recovery from an event? Is there a minimum off time, and can you stipulate a maximum off time for your loads?
I guess it's quite a lot there. So the frequency, it can get quite technical, I guess, but the frequency is oscillating around 50 hertz all the time as the system is trying to be balanced second by second. There are demand and supply imbalances every second of the day in terms of scheduling the amount of generation versus the amount of demand on the system. However, National Grid denotes an event as anything that goes above 50.2 hertz or 49.8 hertz. And that happens around 10 to 20 times a month. But it's important to notify, as Martin alluded to earlier, that we are making very small changes to consumption patterns, even within those deviations. But what is considered an event, which is 50.2 and 49.8, is about 10 to 20 times a month. To answer the second bit of the question, that we can build in parameters to make sure we don't kind of override certain maximum on-time durations, minimum on-time durations. But it's important to note the more parameters we stick around things, the less availability we get. But fundamentally, if certain systems were only designed to run in certain ways, we wouldn't take them outside of those control parameters.
Yeah.
Great. Thanks, David. Another question that's come in, and it's a sort of fairly general question here, but someone's asking, are there any legal or insurance issues which you should consider right at the outset?
Other than the fact we have full sort of business liability insurance, and we kind of make sure we match our customers' requirements on that to make sure they're fully happy with our insurance levels before we do any installation processes. Clearly that's an important thing to make sure our customers have safety and security over any potential disruptions on site.
Great, thanks, David. Another question here. So you mentioned about processes as one of the examples of assets which won't tolerate modulations in power. Can you give some other examples of the type of things that aren't suitable?
Did you say aren't or are suitable? Sorry.
Aren't suitable.
Obviously, lighting. Certain things I would, still steer well away from that are critical assets that are providing a critical service within very tight tolerances. I just wouldn't. But I know those. I have to know those because they're critical to the business. So it is understanding the business and understanding what does what and what can be allowed to vary. But obviously things that are instantaneous to the customer's need. But when you look at it, a lot of things aren't necessarily. That can be varied a bit.
And what I'd add to that is essentially critical loads tend to be controlled in very tight bandwidths, and what tight bandwidths mean is essentially less availability, because the moment you make a switch, the system sort of reacts in a way that things need to come on or off quicker than systems with high tolerances, but our work in, say, commercial refrigeration in supermarkets proves that we can actually work in quite critical environments and still deliver value from that, because it's how we respond at an aggregate level as opposed to an individual asset level that's the most important thing to National Grid. So whilst if we switch a refrigeration asset off very quickly and it needs to come on quickly to make sure it doesn't contravene health and safety standards and the like, that can still perform a very valuable part of our service. So all I'd say is anything with flexibility in it, even short duration amounts of flexibility can offer value to the system, and we have experience of working in critical natures because essentially we're just responding to primary control variables, and however critical that is, we will always respond to the primary control variables first, such that we will never take it outside of its control.
Great, thanks David. So we've got a couple more questions left before we draw it to a close. One for you, Martin. So you mentioned about doing a phase 3 of the project, and someone's asking what made you decide to phase the rollout of the demand response that you've installed?
There's probably 2 or 3 reasons. I mean, one is the amount of time and the thought it takes to think about the particular assets. Another one's come back to you and go, oh, I suppose first off it was risk. I mean, did I want to do a big bang and control hundreds of things without having had the experience? No, let me do a few buildings that I'm very confident are not going to be noticeable. And once I've got that right, okay, let's think about the next lot. And it's part experience, part time. I mean, our other assets I clearly can identify at the moment. We've got a district chilled system with some quite large electric compression chillers on that system. Yes, they could certainly do this, but at the moment I haven't got the time to really engage and think about it, or my team haven't. But yeah, we will get round to it, I'm pretty certain, because the reward, I'm reasonably certain, will be there. I mean, they're 400 kilowatts each, so yeah, there's going to be some financial reward, but we can't do everything all the time. We have to do the other side of energy efficiency and reducing our load. Generally, we have to do other things, providing our energy to our site. So this is just one element, but it is an element that's worth considering.
Thanks, Martin. And final question here. So today's presentation is focused on demand response for the electricity grid. Do you see the same occurring for the gas grid in time? David Hill, do you maybe want to pick up on that one?
Yeah, I saw that question. I mean, I fear we're not going to give a very adequate answer because, as I said, our company is very much focused around the electricity industry. But from my knowledge and speaking to other people, there is movement in the gas industry to start looking at demand response services for the gas grid. But unfortunately, that's about as much information I can give at the moment because, as I said, we are pretty much focused on the electricity grid at the moment.
I mean, from our thoughts on gas, I mean, I saw that question and thought, well, probably not. It hasn't got the same instantaneous 50 circles a second instant response needed. I mean, there's a much slower response and, interruptible tariffs on gas supply that does balance that, but it is a much longer duration event on gas than it is on electricity. It's, very instantaneous. They must supply what is being used. On gas, it's much more of a compressed, stored system in the whole network, and a much slower response, was my thought.
Great. Thanks, Martin. So that's all we've got time for now, but I'd just like to thank David Hill, David Perry and Martin Newton for their time today and getting through so many questions, and also to everyone who's joined us for this webinar. Just to remind you all that a recording of the webinar and the presentation slides will be archived on the 2 Degrees platform, and as soon as those go live, we'll send out an email with the link to those. So I hope you've all found it useful and interesting today, and that you'll be tuning in for more webinars in the coming months. So thank you, everyone.
Right.
Thank you. Thank you.